All right, great. Hey, listen, welcome back. In attendance today in the Sandoval Squad, we got Marcus and Celeste. Good. Now let me, today we're going to be covering 3 lessons because they're all related. And you're going to discover they're just small changes to each one. Now we're going to start with something very important in math, which is volume. So with that, Celeste, why don't you go ahead and read the definition for volume, like right here. What does it say?
The volume of a prism is the product of the area of the base and the height of the prism.
Okay, excellent. Now, Marcus, what's one thing that's very important to know about this?
The equation.
Yeah, but doesn't the equation seem too simple to you? This equation?
Huh?
Yeah, doesn't that one seem like, oops, hold on a second. Doesn't that equation seem like very easy?
Yeah.
Yeah. Why is it so easy?
Well, you're just finding the area. I mean, the volume. It's not hard.
Well, the part that becomes important is that inside this part that I want to point out to you. So let me go ahead. So you see the B part, the one I just highlighted? Okay, that B part wants the area of the base. Okay, so what kind of, when it says about the area of the base, how many shapes can a prism have?
2?
No. How many? Like the base. I mean, like shape of the base. Like how many shapes
infinite.
is the base? Infinite, right? And why is that?
Because there's an infinite amount of numbers that could be sides.
Yeah, you could have like a polygon type of base, right? That goes into like the 20th. And the thing that's going to be beneficial for you is that for the most part, that doesn't exist in our real world. We're going to make the discovery that most things are like this, a cube. So find the area of that base is very easy. It's like length times width, and then you just multiply it by the height. So as a result, we get sx cubed. But other times, you're going to discover that, so apart from like the triangle and if you had to find how do you find the area of the base of a polygon? Like let's say if I had told you like a decagon, which is 10-sided figure, how would you discover that? You remember that it was a apothem times perimeter? So in this case, they made this equation very general, very easy, and it should be that way. Because there's not, there's going to be only special situations you're going to need this, but it's very broad. Does that make sense? So you got to keep that in mind. The most important thing is finding the area of the base. All right, good. So with that, let's go ahead and look at this next equation. Okay. Why is this equation written this way?
Well, because it has a circle as a base.
Yeah. So from here, this would have been our original formula, right?
Mm-hmm.
That is the B part, right? Let me hit undo.
Yeah.
The result is at this little portion right here. That's the B, correct? So that's the thing that why this still transfers over. Does everybody see that? That's why it's so important. Okay, now let's go ahead and come up with a couple of solutions. And Celeste, why don't you run us through? How will we find the area of example 1? Or not the area, sorry. How will we find the volume? Because that's what they want. Lead me through it.
So we have to do the base, so we need to do 8 times 10.5.
Wait a second. I did something. I think I clicked. Oh, I know what I did. I made an extra page. Wait a second, let's get back over there.
It's 14.5, we need 14.5.
All right, good. So Celeste, you said it correctly. So you said that you wanted to, first of all, we start with the formula, right? And you said that you wanted to find the area of the base. So you said 8 times 10.5, correct? Times height, right? So that 8 times 10.5, that's this 84 that you see here as a result. And then after that, you multiply with the height, which is 12. So our solution is you can get that very quick and easy. It's 1,008. All right, good. Do something very similar in this case, 15 times 5 times 15. So we get that version. Let's go with Marcus. Marcus, why don't you go ahead and, how will we do example 2?
Example 2?
Yes.
Well, since this is a cube, right?
Yes.
So it'd just be 4.5 cubed. Oh
It's
wait,
actually
the
not a
base is a square.
cube. I'm
No,
sorry,
sorry.
I
Yeah.
said that wrong.
So it'd be 4.5 squared,
Okay.
which is what? A big number, and times 5.
Yeah. You know what? You're right. It looked like a cube. They actually made it as a cube, but it should have been like you were saying. Let's fix this. Because they said the base is a square, but they said the height's different. So it can't be, you can't use this equation. See how they use that? We have to do exactly what you said. To find the volume on this one, we have to do 4.5 times 4.5. And we do that because of length times width times 5, which is the height. And then we get that as a result. All right, good. Now let's go ahead and move on. So Celeste, how would we do example 3?
So how we would do example 3?
Where is it that, tell me something that, ask me a question. Or ask Marcus a question. What question would you ask Marcus? Marcus, if you had a helper, where is she getting trouble at? If you had a guess at where she's having.
No idea.
Okay. Well, first of all, you got to first start. What kind of prism is this?
Triangular.
Triangular prism. How are you able to guarantee me that solution?
Because the bases that are parallel to each other are triangles.
Yeah, they're parallel and congruent, right? They're triangles, correct? So in this case, now let's start with our formula. Okay. So in this case, what would be the area of a triangle? Give me the formula.
It would be what? 1/2 base times height.
Yeah, but in this case, little b. You see how they use a big capital B there? That's because we want to make the difference that they're not the same. They're different. So as a result, and then afterwards, the height refers to something else. Does it make sense? So this one is the 7, and not the 7, I'm sorry. Said that wrong. That's the 18. So let me go ahead and actually let me switch the color here because then now it's going to help. Let me switch the color and make this red. Okay, so here's that one in red. You notice that? Because remember, you find the height from the distance areas between the bases. And then when you continue doing the solution, you discover that this is the height of the actual triangle, the 7. And then this is the base length, B35. So that's the reason why you have 1/2 35 times 7. But does it make sense to you, Celeste?
Kind of.
Okay, so you see this right here? Okay, that one is that part right here. Okay.
Oh.
That is the area, and let me go ahead and show you. That is the area. So just whatever I'm highlighting in, that's the area of the base. Okay, and that's what I wanted. I wanted the area of the base. The only thing that I have to do to add volume to it is now multiply it with the height, which is this one. Okay, does that make sense? Okay, so then that's how you give them volume. Because remember, the volume is very simple. The formula, the base of the area, which is this one, times the height. And then you get that solution. Okay, and you'll see it here. Let me prove that result to you. Hold on a second. Right here, 122.5 times 18, and we'll discover that. Now, one thing that is new that you should feel safe with is that now we're dealing with a cube. So we see that we're multiplying 3 things together, 3 numbers. Okay, good. All right, Marcus, go ahead and lead us through B. How will we solve for B?
B?
Yeah. B is the one. This. I think I might have covered up the letter B on here, but it's the one to the right of everything we're working on.
Oh, okay.
Let me
So
read
it would just be base times height, and they've already given us the base, which is 77.
Mm-hmm.
Then the height is 25.
Yeah.
So it would be 77 times 25, and that's.
Yeah, 77 times 25, and then you get that amount. Now, important, Celeste, does it make sense to you?
It makes more sense now.
Makes more sense, right? Because you got the base there, which is that triangle. And one thing that I do love about what they did in this one is that they highlighted the triangle, this portion right here, so you can know that that's the part that they're getting the area from the base in order to make the equation complete. All right, so now let's move over to this part. And all right, so Marcus, walk me through, how would I solve A?
A?
Yeah, because now they want the volume of a cylinder.
So that'd be 8.5 pi squared?
Yeah.
No. Or is
So,
it pi 8.5 squared? Okay, yeah, pi 8.5 squared times 7.
Good. Yeah, and you get that as a result. All right, so let's lead me through B. How would I solve B?
B. Okay, so let me see. Sorry, I just usually look at what Marcus has done before and then I try to follow those steps.
Well, that's a good thing, you know, and that's because that's one of the ways you learn. So when you're looking at B, what can you tell me? Like what some things are important for you to discover here?
So the 10 and the 2, because the 10 is
Yes,
where
I
the
know. Good, but what do they mean as far as letters and with the equation? Translate that to results on the equation.
so the point
You know what the 2 means?
okay, so the 2 means for the pi. Like it's
Radius.
supposed to be next
Yeah,
to
the
the
2
pi.
is the radius. Remember, radius is always the center to the outside, right? So there's your radius. And then the 10 represents the height, which is the difference of bases. So as we solve this one, it leads into using the equation, 8.5 squared and then times 7, so we get that solution. All right, now let's do the very last one on this one, and then we'll move on to the next ones. All right, now let's go ahead, Marcus, and read this one out to me. Or how will you solve this one?
Which one? Example 5?
Yeah, example 5.
Okay, so the red cylinder has a diameter of 8 feet and a, what does that say?
Mhm.
Sorry, I can't see that.
Oh, it says, and a height of 15.
Height of 15 feet. Okay. So, well, we know the R is 4, so it would just be pi 4 squared times 15, which is just pi 16 times 15.
All right, excellent. All right, good. Now, using the same idea, let's go ahead and now shift gears. We're going to move on to the next one because they're all related. But now we're going to talk about finding volumes of pyramids and cones. Now, so Celeste, what's the only new thing you find equation compared to the last one we're using?
Compared to the last one was the pyramid. Well,
The prisms, remember. The prisms.
yes, the
Remember,
prism.
we started with this broad equation. So what's new? What's different between this one to this one, the one that's in square?
Well, there's 1/3.
Yeah, so it's very similar. So the thing that I love about it, it's all the same. Just one new step you have to add to it. You multiply a third. So it's a third less. And it makes sense because if you notice, it's like kind of like a prism but cut out. So 2/3 have been cut out. So you're only going to keep a third of it. All right, so with that idea, and the same thing with the cone. Does everybody notice the cone was very much like a cylinder, but the only thing that's new about it is a third?
Yeah.
All right, good. So Marcus, lead me through A. How would I solve A?
A?
Yeah.
Well, so we know the base is 64, so that's 64 times 10 divided by 3.
Yeah, good. So that's how you get that amount. Okay, or multiply by a third. So, but it makes more sense to divide it by 3. When you see a third and dividing by 3, that, right. So Celeste, lead us through the next one. How would you do the next one?
So the base is 1.44.
Good.
And then the height is 2.8.
Actually, the height is not 2.8. The height, and they gave you one thing that is different about this one, because does everybody see everything in green right here?
Yeah.
Marcus, why did they do all this stuff in green?
Oh, because they weren't given the height, but they were given that slant angle, which is 2.8.
Yeah, you were getting slant height.
Backwards.
Exactly.
Yeah.
So slant height, and they went ahead and used some of the 0.6 came from half of the 1.2. And then afterwards, they used Pythagorean theorem backwards to find out the height. So the actual height, Celeste, just to kind of clear this up, that's going to be important, is this one right here. It's at 7.48. Okay, so now you know height 7.48. What is this going to look like in the boxes? Here's the formula.
We're gonna do 7.48 times 1.44 divided it by 3.
Yes, good. And you get 1.3. Now, I should have mentioned it was the square root of 7.48. They kept it as a radical in order to keep it whole as a solution. All right, good. All right, Marcus, lead us through example 2. How will we do example 2 on this one? And this time it's a cone.
Just wait. Okay.
Do you see it?
Yeah. Okay. Sorry. So example 2, you want me to do A or B?
Yeah, do A.
Okay. So we have a height of 24, and then we have a radius of 7 because you know the diameter is 14 divided by 2 thing.
Yes.
So that would be 7. No, that would be pi times 7 squared times 24
Okay, good.
divided
So-
by 1/3.
Yeah. So then you get that 3. So they went ahead and kept everything in pi, and then they went ahead and utilized it. Okay, so let's say, how will you do B?
Oh, sorry, I was just trying to analyze because I was a little bit off.
Oh, you were? Okay, tell me in this part, what did we lose you at?
So so you did 392 pi equals 1,232. How did you get that?
Well, here. First of all, I think what's more important, Celeste, that I think you need to find out is that there's really only 2 things you're looking for in this equation. Oops, hold on, that's too big. And use a smaller R and H. Those 2 things. Let me try to make that highlight on top.
And the
of it.
1/3.
Yeah, and then you use and you use pi, but those are fixed. Like I could guarantee you right now, if I wanted to, I could go ahead and take 1/3 and multiply with pi and give you a number. But what changes is the radius and the height of each one. So then what Marcus did is that he looked at the radius. Remember, radius comes from the circle. You can't get it from anywhere else. And he was given the diameter. Now, once he was given this diameter, he went ahead and said, okay, you can take the diameter divided by 2 and you get radius, because you only get half the amount. So this is 7. Okay. Now, height was given to him. So the only thing he had to do is really just put it into this equation that you see there, into the R and the H. So you see how it's 7 squared and 24? So those are the 2 things that are most important to actually be able to implement into the equation. So using that same train of thought, Celeste, how would you do B?
How you will do B? So if the 5 was for the radius, you have to do that. So then that will be 2.5.
Yeah, that's excellent, Celeste. So 2.5 is the radius.
And then times 15 since that is the height.
Yeah, the only thing you got to keep in mind is that the radius is squared. So the 2.5 is going to be squared. And then afterwards, you get that solution. Good. All right. So now let's do our last volume one that's important for us that we're going to cover. That has to do with spheres. So in this case, oh, and we're also going to throw something new since we haven't covered this yet, and they're both related. There's going to give us a surface area of the sphere, but that's kind of new. And then the volume. So Celeste, why don't you read the surface area of the sphere, the equation.
The surface area of a sphere is 4 times the product of pi and the square of the radius of the sphere.
Okay, so that's why we're given this. Oh, hold on, I moved. That's where we're given, oh, hit undo to put everything back the way it was. Oh, I hit undo a few more. Wait. Let me go back. No, hold on a second. I gotta go back down. So I could use my, well, I'm just gonna move, well, hold on. Yeah, let me use just this. All right, excellent. Okay, so Celeste, going off that, then this is how we get this equation. Exactly what you did. All right, Marcus, read the volume of the sphere.
Volume?
Yes.
Okay. The volume of a sphere is 4/3 the product of pi and the cube of the radius of the sphere.
Okay, good. All right, so Marcus, tell me something that both of these equations have in common.
Pi and r.
Yeah, good. Now, which of these is the only thing I need to really find?
Well, r.
R, right? Okay, so the only thing you have to really use is radius. Okay, so in this case, let's work through these right here. Okay, so this says find the surface area of each one. So Marcus, why don't you go ahead and do A? How about you do A?
A?
Yeah.
So we know that the diameter is 8, so we have to divide that by 2 to get the radius, which would be 4. So
Okay.
then that's 4 pi 4 squared.
Yeah, so you get up a 64 pi is guaranteed to be your surface area. So let's say, how would you do B, the next one?
The next one. Wait, we can take are you guys on example 3?
Yeah, we're doing this one. Let me highlight it for you so you can see it.
Because so the
Okay.
phone is a smaller screen.
I understand. Okay, why don't you go ahead and read that or see that?
So that's 5 centimeters.
Yeah, good. So then what do you do?
So what you will do is, so sides equals 4 pi RT, so that means it is,
4 pi 5 squared. If you know R is 5, that's the only thing you're really searching for. This R is 5, then you just input into the equation. So in some sense, these are very easy. Because then after you do you get that amount. So like Marcus, what should the next one be?
Next one.
Yes.
Okay, so the next one has a diameter of 6.
Yes.
The radius would be 3.
Good.
So just be 5 pi 3 squared.
Yeah, 4 pi 3 squared, right? So
4 pi 3
3
squared,
squared is 9, so 4 times 9 is 36. So we end up with 36 pi. Okay, good. All right. So now, Celestin, we're going to shift gears. I'm going to ask you to find volume. How would you find the volume in this one?
for the volume.
Yeah, and there's the equation. It's 4/3 pi r cubed.
So what's missing? So why is the 4 bigger than the 3 at the bottom?
Why is it bigger? Well, because when they came up with the equation, they discovered that it was a ratio that was larger. Does it make sense? Like a sphere, like a volume is bigger than would be 3 divided by 3 is 1, right? We found out that the volume was 4/3 pi r cubed. Slightly different, 3 dimensions, and it was a slightly higher ratio. Okay, so you just have to know that this formula works. I can show you the mathematics, how they came up with it, but it involves things that are like above what you understand with math. Like I have to get into calculus. Okay, so in this case, you just have to know at this moment that this works. Okay, that formula works. But what's the only thing you need to find out to use this formula, Celeste?
I need to find the radius.
Good, so what's the radius of that sphere?
18.
No, why not?
No.
Why is that wrong?
Is it 9?
It is 9, but you said originally 18.
Because I forgot to divide it by 2.
Yes, so it's very important. And actually that thing that you thought about, something that a lot of people think about, unfortunately, when they see sometimes images, they just automatically take it. So you want to make sure first you're able to analyze it and then find out, is that the right solution or not? So now that you know 9, what do you do with it?
So you do it with the radius.
Yeah, so you place into the radius. So 4/3 pi. Now you're going to do 9 cubed. So that's 9 times 9 times 9, which is going to be, when you multiply with 4/3, comes out 972. It's kind of a big number. Because 9 times 9 is 81. So 81 times 9, that throws it up there, and then you multiply it with 4/3, and you get that result. And then the next example is actually easier. You agree, Marcus? The next example is actually easier than the one you said.
Yeah, it's only 3.
Yeah. Just got to put in 3 in there, and you get that solution. All right, good. Hey, great. All right. Hey, listen, so we went ahead and covered everything to do with volume. Thank you guys so much. Go ahead and share it, look at this, see it a few times, and thank you, kids. Thank you, Marcus and Celeste. Take care.
Goodbye.
Bye.
Bye.